Welcome to Episode 13, Benefits of High Availability and Scalability. Every modern application must balance resilience and performance, the ability to stay available even under stress while still responding quickly. These two goals are related but not identical. Performance is about how fast a system responds when things work well. Resilience is about how gracefully it handles when they do not. In cloud environments like Azure, designing for availability means preparing for failure as an expected event, not an exception. Designing for scalability means ensuring the system can handle growth without breaking. Together, they define how reliable and adaptable your application truly is. Availability targets and service level goals help translate technical resilience into measurable expectations. Organizations define uptime objectives such as 3 nines, meaning 99.9% availability, or 5 nines, meaning only a few minutes of downtime per year. Each additional 9 becomes exponentially more expensive to achieve, so choosing the right target requires balancing cost and business impact. Service level agreements, or SLAs, describe what the provider guarantees for each service. Azure publishes these metrics so customers can build systems that meet their own goals. Aligning internal service levels with external SLAs prevents mismatched promises and creates a shared understanding of reliability expectations. Scaling is how systems adjust to workload changes, and there are two primary forms: vertical and horizontal. Vertical scaling means adding more power to a single resource, more CPU, memory, or faster storage. Horizontal scaling means adding more instances that share the load. Vertical scaling is simple but limited by hardware. Horizontal scaling is flexible but requires designs that distribute work evenly. Azure supports both through features like virtual machine scale sets, app service plans, and container orchestration. Knowing which method fits your architecture determines how smoothly your system grows. True scalability often comes from designing horizontally, so no single node becomes a bottleneck. Autoscale thresholds in health probes bring scaling to life. Thresholds are the performance metrics that trigger scale-out or scale-in actions, such as CPU usage exceeding 70% for a sustained period. Health probes continuously check whether an instance is functioning correctly. Together, they allow the platform to react automatically to changing conditions. For example, if a web app slows under heavy traffic, autoscaling can add more instances while health probes remove unhealthy ones from the pool. This automation keeps performance consistent and minimizes manual intervention. Fine-tuning these thresholds is an art. Too sensitive causes churn. Too slow causes lag. Redundancy across availability zones and regions protects against localized failures. Azure divides each region into multiple physically separate zones, each with its own power, cooling, and networking. Deploying resources across zones ensures that a single data center issue doesn't disrupt service. For even greater protection, multi-region deployment replicates workloads across geographic areas. This strategy supports disaster recovery scenarios where one region fails but another takes over seamlessly. The extra distance introduces complexity, but the resilience gained often justifies it for critical workloads. Designing with redundancy is like carrying spare tires. You hope not to use them, but you'll be glad they're there. Handling stateful data adds unique challenges in distributed systems. Applications that keep track of sessions, transactions, or user preferences must maintain consistency even when nodes fail. Quorum patterns, where a majority of nodes must agree before changes commit, help prevent data corruption. Technologies like Azure Cosmos DB or SQL Database with zone redundancy provide built-in mechanisms for replicating and reconciling data. These systems trade a bit of latency for durability. Understanding how your application handles state, where it lives, how it's replicated, and when it syncs determines how reliably it can scale without losing correctness. Load balancing is the technique that keeps requests evenly distributed. Azure offers multiple options: internal and external load balancers, application gateway for web traffic, and traffic manager for DNS-based routing. These services watch traffic patterns and distribute requests to healthy instances automatically. Advanced routing strategies can prioritize certain regions, favor low-latency connections, or shift users away from failing systems. Load balancing smooths out the unpredictability of user demand and turns clusters of servers into a single, unified service. Done well, users never notice the distribution is happening. They simply experience consistent performance from anywhere. Graceful degradation is how a system remains usable even under extreme load. Instead of crashing completely, it temporarily limits features or reduces response quality to preserve core functions. For instance, an e-commerce site might disable recommendations during heavy traffic but still allow checkout. Azure services often support throttling, queuing, or circuit breakers to manage this behavior. Designing for graceful degradation accepts that overloads happen and focuses on minimizing their impact. It's the digital equivalent of a car's limp mode, less power but still moving safely forward until full capacity returns. Planned maintenance and rolling updates are part of operational resilience. Azure performs infrastructure maintenance regularly, and applications must handle these events without disruption. Using availability sets or multiple instances allows updates to occur one at a time so users never see downtime. Rolling updates also apply to your own deployments, pushing new code to a subset of servers, verifying health, then expanding gradually. This approach reduces risk and makes rollback easier if something breaks. Maintenance resilience is as important as failure resilience because most outages come from change, not catastrophe. Capacity buffers prepare your system for predictable surges like retail holidays or product launches. Azure makes it easy to allocate extra resources in advance or to set autoscale rules that anticipate peaks. The idea is to stay ahead of demand rather than chasing it. A well-tuned buffer absorbs unexpected bursts without overpaying for constant excess. Historical usage data and monitoring trends guide how much buffer to maintain. For businesses, the goal is steady customer experience even when traffic doubles. Capacity planning may sound old-fashioned, but in the cloud, it remains an essential discipline for smooth operation. Testing failure modes proactively turns resilience from theory into confidence. Instead of waiting for problems, teams simulate them using chaos testing, intentionally shutting down components to observe behavior. Azure's testing tools and patterns make it possible to see whether autoscaling, load balancing, and failover actually work under stress. These controlled experiments reveal weak points before they cause outages. Regular testing also strengthens team response skills, transforming panic into practice recovery. The time to discover that a backup fails is not during an emergency. By rehearsing failure, you make resilience part of your culture, not just your architecture. Monitoring signals guide scaling and recovery decisions. Metrics like CPU usage, queue length, error rates, and response times provide early warnings about stress. Azure Monitor and Application Insights collect this data, turning it into dashboards and alerts. These signals tell you when to scale, when to investigate, and when to celebrate stability. Automated scaling rules depend on these metrics to act accurately. Over time, patterns in monitoring data reveal trends, seasonal cycles, growth rates, or configuration drift that influence long-term planning. Monitoring is the nervous system of your cloud environment. It senses, reacts, and learns continuously. Every discussion about availability ends with the cost-resilience trade-off. More redundancy, higher SLAs, and broader failover capabilities always add expense. The challenge is to spend where it matters most. Not every system needs 5 nines uptime. Some can tolerate short downtimes for far less cost. The art lies in matching investment to business value. Finance and engineering must speak a shared language. What does one extra 9 of availability mean in dollars and reputation? When those conversations happen early, architecture and budget work together instead of at odds. Adopting availability-first thinking means designing with failure in mind from day one. Expect components to fail, networks to glitch, and workloads to spike, and ensure the system survives anyway. Measure success by user experience rather than uptime percentages alone. When availability and scalability are treated as fundamental design principles, every part of your cloud architecture becomes more robust. Azure provides the building blocks. Your mindset provides the discipline. Thinking this way transforms reliability from a reaction to an expectation, ensuring your applications perform gracefully no matter what the world throws at them. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.